Can we travel faster than light speed? Stay tuned to find out. Greetings, friends. Julian here for DNews. If you're a fan of sci-fi, you're probably familiar with the convenient plot device called a warp drive. Now, I'm not the biggest Trekkie, so I had to bring in a little outside help. He should be here any minute. Trace, would you mind telling the folks at home exactly how Star Trek's warp drive works?
Certainly. Federation warp drives operate by combining matter and antimatter through a matrix of dilithium crystals that generate high-energy plasma, which, when funneled into the ship's warp field coils, warp the space around the ship and allow it to surf on the distortion that is faster than light speed.
Okay, thanks. You can go now.
Oh, okay, well, I guess I'll get a cab or something.
So, how much of that was actually plausible and not just crazy mumbo-jumbo? Well, the practical way of generating the warp field is pure science fiction, but the warp field itself is mathematically possible. In 1994, Miguel Alcubierre published a paper in Classical Quantum Gravity that demonstrated how a warp drive was possible without violating general relativity, which says that no object can go faster than the speed of light. Alcubierre showed that if a ship could expand the space behind it and contract the space in front, it could travel at what he called an arbitrarily large speed. To an outside observer, it would appear to travel faster than the speed of light. The ship itself isn't technically breaking the cosmic speed limit because it's not the ship that's moving, the bubble of space it's sitting inside is. It's like the physics version of "you can't tell mom because I'm not touching you." So, how could we bend space to our whim? In practice, it's a bit tricky. Alcubierre himself points out that in order to generate a warp bubble, you'd need exotic matter, specifically negative energy. And I don't mean pessimism, I mean energy that's totally opposite in the sense you and I know it in. It's tough to explain, but think of it this way. Mass bends space-time in on itself, and we experience that as gravity. Energy is equivalent to mass times the speed of light squared. So if you have enough negative energy, it bends space-time like a saddle. Sounds bonkers, but that's what the math says. Alcubierre thinks if we can harness enough negative energy and arrange it to bend space correctly, we could travel at warp speed, and the benefits are pretty obvious. Traveling between stars and galaxies suddenly becomes a snap. Plus, the crew on the ship doesn't experience time dilation like they would if they had traveled through space conventionally at near light speeds. So when they get where they're going, they're not suddenly thousands of years in the future and everyone they know and love back home isn't dead. So why aren't we funding this? Well, while we have indirectly observed negative energy experimentally, it's only been in tiny amounts. To get a warp bubble around a small spacecraft, you'd need a whole bunch of it. At first, scientists calculated it would take 10 times more negative energy than there is positive mass in the visible universe. In 1999, Chris Vandenbroek tweaked the shape and thickness of the bubble and got that number down to the equivalent of just a few negative solar masses. Oh, and you'd also have to harness the mass energy of a few regular old positive suns to boot. Our own in-house astrophysicist Ian O'Neill interviewed Dr. Richard Obusi, who had proposed instead we use dark energy, the stuff responsible for accelerating the expansion of the universe. If we put that to work, Obusi estimates we'd only need about the mass energy contained by Jupiter. Sounds comparatively easy until you remember that we still have no idea what dark energy actually is, let alone how to generate a Jupiter's worth. Still, when you consider that propelling a spacecraft to the speed of light with a conventional rocket would take infinite energy, using one paltry Jupiter's equivalent of dark energy to go faster than light is comparatively a bargain. As if generating huge amounts of negative or dark energy wasn't hard enough, there are other hurdles to overcome. William Edelstein of Johns Hopkins suggested that traveling faster than light through the thin interstellar gas would be fatal to the spaceship's crew. Researchers at the University of Sydney proposed that particles in the ship's path would get swept up, and when the ship decelerated at its destination, these particles would be launched like a shot put, with enough force to potentially annihilate entire planets. Alcubierre even wrote that once the bubble is going faster than light, the ship inside can't send a signal to turn it off, so there's no stopping. There's not much point in warping somewhere if when you show up you're dead or everyone else is dead or you can't stop. Of course, it's all just theoretical at this point, and we're still decades or even centuries away from making real headway. Is the Enterprise's warp drive possible? The answer is a very technical yes. Figuring out better space travel is fun and a great goal for the future. Figuring out better air travel is fun and a great goal for now. To figure out if planes can ever be environmentally friendly, check out Trace's video here.
At the end of 2014, the world's first biofuel-powered plane took off in Canada. The biofuel was made using rapeseed oil, though the researchers pointed out it could have come from flax, coconut husks, cooking oil, or just algae.
So, let's say someone builds the first warp drive and they're looking for volunteers. Would you sign up? Let us know in the comments, subscribe for more, and I will see you next time on DNews.
Oh, the teleporter!